Hello, everybody. All right, today we're going to look at modeling with quadratic functions in vertex form. Okay, so today we want to be able to model the equation or write the equation of a quadratic function given its vertex and another point on the parabola. Okay, so we're going to use this when we are given the vertex and another point. Okay. So here, the graph shows the parabolic path of a performer who is shot out of a cannon, where y is the height in feet and x is the horizontal distance traveled in feet. We want to write an equation of the parabola, and then we say that the performer lands in a net 90 feet away from the cannon, and we want to know what the height of the net is. We can totally do this, okay? So number one, write the equation of the parabola. This is the more complicated part. This is definitely the harder part. And the thing we got to remember is that vertex form is y equals a times x minus h squared plus k. Now let's go ahead and look at this parabola that was given to us. I think right away we can identify the vertex by looking at this. It's 50, 35, right? So therefore I know h and k, and I can plug those into vertex form. So I'm going to have minus 50 squared plus 35. But I actually know something else too. I was given a point on the parabola, 0, 15. Now, that happens to be the y-intercept, but it's not actually very important that it's the y-intercept. It just needs to be another point. And therefore, that is an x value and a y value. So I can go ahead and plug in 0 equals 15, okay? So the only thing I don't know is a, and if I only have one variable in an equation that I don't know, I can go ahead and solve for it. So I just need to solve for a. I knew x, I knew an x value, I knew a y value, I know my h, I know my k, and now I'm going to solve for a. So I'm going to start by just doing 15 equals a times negative 50 squared plus 35. 0 minus 50. Negative 50 squared. 50 times negative 50. Well, that'd be positive 2,500. So 15 equals 2,500a plus 35. A times 2,500. So now I have a very simple equation to solve. I subtract 35 from both sides, right? I'm going to get negative 20 equals 2,500 a. And then I divide by 2,500. I get a. I'll scroll down a little bit just so I can write in the bottom of my screen here. A equals negative 20 over 2,500. And we should be able to simplify that, the zeros. And then I have negative 2 over 250. So that's negative 1 over 125. You could simplify that to a decimal, express it as a decimal, but we're just going to leave it like that. And therefore, that tells me, remember that I have y equals a times x minus h squared plus k. So if I want to write the equation of the parabola, I just need to plug in a, h, and k. So my equation is y equals negative 1 over 125 times x minus 50 squared plus 35. And there's our equation. That's the equation of the parabola that was given to us over there. Now, I have a second problem. It's saying the performer lands in a net 90 feet away from the cannon. What is the height of the net? Well, 90 feet from the cannon. That is an x value, right? It refers to a horizontal distance. So I'm just going to plug in 90 for x and solve for y. Y equals negative 1 over 125 times 90 minus 50 squared plus 35. So now I just solve for y. I'm going to do 90 minus 50 is 40. Negative 1 over 125 times 40 squared, and then I'm going to add 35 to that. So y equals negative 1 over 125. 40 squared would be 1,600. If you need to use a calculator, that's okay. So we take 1,600 and divide by negative 125. And I get y equals negative 12.8 plus 35. So now I just got to add 35 to that. So y equals 22.2 feet. And there you go. What I'd like you to do next is there's a second example here. Write the equation of the parabola. Then find the height when x equals 10. I didn't give you a picture this time. I just told you what the vertex and the point were. I want you to try that what we just did, this exact process out, but with these numbers, okay? We're going to go over this in class, but I want to make sure that you know exactly what you're doing and you try it out. And then that way you can come in with questions. Thanks, guys, and have a good day.